Arjumand Yaqub is from Qualcomm. He holds a bachelor's and master's degree in electronic engineering and brings extensive experience from leading technology companies, including Qualcomm and Intel. Currently based in San Diego, California, Arjumand works as a staff engineer focusing on advanced design and verification solutions. Over to you.
Hi, thanks for the introduction. Good afternoon to everyone. It's myself, Arjumand Yaqub. Today, I'm going to present in this session AI in DV. You can see the title of the presentation. Basically, I'm going to present about different AI strategies and tools that we have deployed to basically and model for the design verification environment development, and we have evaluated and seen that what are the artifacts and what are the benefits of doing that. So as the abstract of this discussion, that will definitely is going to be based on all this AI model and strategy and the flows that I'm going to present, and to show you that how efficiently this can basically affect in developing an efficient and an accurate design verification environment. And we'll present this in this whole presentation. So as an outline, how we are going to do is that basically first I'm going to present about my proposed strategy and the model. And then that will definitely include how UVM test pen generation is also augmented in this whole package, and how this whole package is basically driven. And then the different techniques and different tools that basically are embedded into it to basically drive the whole flow, and the effect of this to basically compare as a result from deployment of this AI strategy and tool and model that is being presented. So one thing is basically from the start, what I am going to present here is definitely setting the ground for how the strategy and the model is basically structured in this presentation that I'm going to present. Because you see in a regression cycle, or when we are running the whole set of regressions in a verification environment and in any kind of design verification environment, the main focus is to cover is to set our coverage goals and to basically get our score in order to sign off for the verification. So basically how it is basically being driven is basically we have a bunch of tests, and these different tests are either auto-generated or written, and they basically are running different several sequences. So in that sense, basically the main aspects are like how these tests are generated and how these tests are directed, and how efficiently we can select a set of tests that basically give us the most of the coverage. So in these three flow diagrams, you can see that that basically how we are going to do is that based on the coverage feedback, the ML model that we employed basically is going to set that how the test generation is going to affect and how the tests will be generated, and then how we want the test to basically generate a particular stimulus scenario based on what we want to cover and what we want to basically hit. It's basically also controlled by like, for example, the constrained random verification environment, but the model is going to basically guide the generation of the test. And also the most effective thing is that in the verification scenarios where we are running hundreds of thousands of tests, the most important thing is that how effective our tests are with respect to the coverage. So the model, which we'll see in the next slides, basically will basically describe that how we are going to select from a bunch of like tests, from large set of tests to more effective tests based on the features and the coverage feedback, and combining all these three basically is going to define our coverage flow integration of AI and ML into our strategy for the whole defining the whole verification environment. So basically, that is all based on the coverage feedback, and the model is receiving the coverage score, and then it's using the different learning techniques and basically biasing the test and the coverage and prioritizing those which are needed to verify and get a high score for the coverage. And that's basically is all based on the training set and data that is working in a mechanism like this that I'm going to show you in the next screen. So this basically all starts with is going to be start with the specs input that we have. And then what is in our flow is that we have a Python generator that is going to create the test bench. Basically, this is a UVM test bench, and the detail for that I will present in the next few slides. And then definitely whenever we have the test bench, we have the article design, we're gonna simulate it, and then we will get our verification goals. But then definitely from these verification goals that we compare, we are going to apply these strategy input models, which are based on different machine learning techniques, and then they are going to control how we are going to generate our test bench and test our stimulus in terms of tests and sequences. So that whole feedback flow is basically going to help in the knobs and configuration for the parameters to this test bench generator. And then we finally have a system Verilog UVM test bench that with the article design we are going to simulate, and we're going to measure our results. So that basically integration of that into an auto generated UVM test bench basically is going to give us like how this presented AI strategy and the model is going to affect and give us the effects of employing the machine learning techniques and the AI model that is proposed there, and how it basically going to guide the stimulus and generate the verification environment. So just going to a bit more into the details of quickly through this UVM test bench generator that basically has been shown in the last slide. It basically is based on a Python script, and it reads the design and interface files and the configuration files, which basically define all the attributes. As you had seen in the last slide, these configuration files are the main point for this AI and ML model, basically, because they are going to control different parameters and the generation of the test input and the sequences. So as a whole in the picture, this UVM test bench generator is going to generate the test bench, which will generate the all test bench related files and the tests and the sequences. But with integration of this AI model and the flow, it's goes basically will guide the stimulus based on how we want to basically get our goal, score the coverage quickly, and so on. So in this slide, basically you can just see that a bit more details of this UVM test generator. As the input, it will be reading the design and interface files. The configuration, there are a bunch of configuration options. There's just some snapshot is here that basically you can specify based on what kind of configurations you want to put in your when you're going to generate the test bench for a particular design you're working on. And basically the tool will incorporate this all and will generate the test bench output. Now this configuration files, as we have shown in the previous slides basically, and also in the slide where we're seeing the coverage flow integrated model in this slide, is basically going to take the inputs based on the coverage feedback flow and the results, and apply these different machine learning techniques to guide the stimulus as per like how we are going to generate, how we are going to direct, and how we are going to select the most effective tests from the selection of the large suite of tests to basically quickly close our coverage for a particular design. So definitely the UVM test bench output will be looking like this. That it will be a kind of a UVM test bench with environment and all other files that everyone knows. It's going to be generates just an example snapshot here that has been taken. So from that perspective, now in the next few slides, what I'm going to describe is that this whole flow and model as a generic is how is it going to be helpful in many different scenarios. So from this deployment, we can see that we have different steps where one thing is the UVM test bench automation that is quickly reducing our time to generate a test bench with accuracy and consistency, and also basically deploying this in the bigger picture in this whole flow and model. There are definitely challenges always when we are going to deploy this in a bigger picture in some designs which are like the randomly in different designs which will pose different challenges. But what we are seeing as a roadmap here is that um, the flow is very well integrated to basically use the different AI and machine learning techniques to generate the guidance and the flow for generating all the test data and based on the coverage feedback, and then basically it has the control knobs where it is going to control the generation of the stimulus based on the configurations and other parameters. And all this is basically using different AI techniques to optimize and to deploy it. So this is just a kind of a bigger picture, and then definitely this is currently in the SVUVM, but basically the output can be in different forms for all of these different basically standards that we have. Uh, so when we are talking about the model and the techniques, and the main objective is to get the efficiency across, and then definitely to cover the bugs and to cover the early enablement of the flow where we can just develop the test bench and we can just guide and run stimulus, which basically is based on different ML techniques that have been deployed here, or that can be deployed there to basically fine tune your process. So this is all based on like how the training model and the methodologies are developed, and how the this enhanced verification pipeline is going to work. This will combine the coverage and score measurement and the test generation, and with the help of different training models, we're going to achieve different results. Definitely, there are like many advanced techniques that can be lumped in, that can be combined, and that can be used in this model to basically develop the training models, and how we're going to train the input data, and how we are going to basically deploy this flow that was presented in the earlier slides. And another extension is that we can use that for the debug automation, that how we are going to basically get debug a failure, and how we are going to basically predict a failure and isolate that failure and then test that failure. That can also be integrated into this flow, because that is also one of the main aspect that we can employ in this. So as a summary, the key features basically are that this is a powerful way of optimizing the test for in your design verification environment, and it can also help in basically prediction of the bugs, and even though can be extended for the post-silicon validation, and can be extended for the formal verification and the formal techniques. But definitely, whenever we are going to scale this model and whenever we're going to deploy this model in the big in the big real designs, the challenges are always about the model. Uh, it- about the model itself and the scalability and the verification of the AI which is involved in itself. So basically, we have different fold challenges which will need to be considered whenever we are going to deploy this in the more details and with the with combination of all of this. So uh, what we basically have as in a summary has presented over there is the automation, test bench automation, and the integration of this test bench automation with the AI and ML based technique to drive the coverage flow and to basically guide the test bench generation and the test and sequences generation here, which basically is going to be help in many in several different ways, where we are going to see the effectiveness of automatically generating test bench and basically employing these AI and ML techniques to effectively generate an effective stimulus and scenarios for the verification. Uh, and then definitely enhancement is based on many different points where we can integrate different enhancement scenarios here and make this model more effective and more you can say more complete to add all of these different techniques and flows that incorporate other scenarios. So as a conclusion, but basically, I can see that uh, we basically in this effort we are like going to implement the this automated test bench generation flow with integrating the different models and the techniques and this proposed model and techniques are basically based on drive the the verification flow and the generation of the stimulus data, and then it basically as a result we get the stimulus results and the debug data and the regression data, which definitely is a set of inputs for the further modeling and for the further training of the ML models that we have. And this whole feedback flow is basically employing different ML techniques, but there is a room of and there is a large set of selection and training that is ongoing to basically improve these as a whole result. So combining this all in a package is basically that is going to give us an effective use case or model that we uh, can deploy to different designs of different complexity and length, and to see that how effective we are going to uh, how effective we are coming after after deployment of all of these, and then this can further guide us to basically give us more details and to more insight to improve on the models and the technique. So I think that's it basically from my side for today. I hope I am almost on the time that was allocated for me. Yeah, and I should be open to. Yeah.
So thank you. We are running a little bit late, so I'm going to be very mean. You have finished slightly early, but I'm going to be mean and say there isn't really time for questions. But can we give our thanks to?
I can answer the questions in the chat. Yeah, definitely.
Okay, thanks. So I think we should move on. So if you could stop sharing your screen, please.
Yes, sure.